Hello students, welcome to Saurav Sir's classes. The question is, for a set X, let Px be the set of all subsets of X and let omega x be the set of all functions f x to 0, 1. Then option A, if x is finite, then Px is finite. Now this is correct since if x has n elements, Px has 2 to the power n elements. Option B, if x and y are finite sets and if there is a 1-to-1 correspondence between Px and Py, then there is a 1-to-1 correspondence between x and y. Again, this is correct since if there is a 1-to-1 correspondence between Px and Py, then 2 to the power mod x is equal to 2 to the power mod y implies mod x is equal to mod y, and hence there must exist a 1-to-1 correspondence between x and y. Now option C, there is no 1-to-1 correspondence between x and Px. It is a standard result that there is no onto map from a set to its power set. So again C is correct. And option D, there is a 1-to-1 correspondence between Px and omega x, as mod omega x is equal to 2 to the power mod x is equal to Px. So there is a 1-to-1 correspondence between Px and omega x. So D is correct. So all the 4 options A, B, C, D are correct. The next question is, let D and D dash be metrics on a non-empty set X. Then which of the following are metrics on X? Now, for option A, sum of two metrics is always a metric. So option A is correct. Now for option B, the product may not be a metric. Consider the real line with matrix d1 xy is equal to mod x minus y and d2 xy is equal to minimum of 1 and d1 comma xy. So option B is incorrect. Now for option C, if row 3 xy is equal to 0, this implies maximum of dxy d dash xy is equal to 0, which further implies dxy is equal to d dash xy is equal to 0, which implies x is equal to y. Similarly, we can verify all other properties. So option C is correct. And option D, this is not a metric space. We can see the following counter example. So the counter example is, let d1 xy is equal to root over x1 minus y1 squared plus 1 by 9 x2 minus y2 squared and d2 xy is equal to root over 1 by 9 x1 minus y1 squared plus x2 minus y2 squared. Further, let x is equal to 1, 0, y is equal to 0, 1 and z is equal to 0, 0. So dxy is equal to minimum of d1xy d2xy, that is root over 1 by 9 plus 1, which is greater than 1, and dxz is equal to minimum of d1xz d2xz, that is equal to 1 by 3. So d1xy is equal to 1 greater than 2 by 3 is equal to dxz plus dyz. Therefore, the triangle inequality is not satisfied. So, option D is incorrect. Therefore, option A and C are the only correct options.